Hi everyone, my name is John Roselli, and this webcast is on scoring the test, performing an item analysis. Before you watch this webcast, please read the required readings. It'll help you along. So by the end of this webcast, you'll be able to describe the elements of an item analysis and use those elements to interpret item analysis data. Well, what is an item analysis? Well, it's a process of statistically examining both the test questions and the students' responses to those test questions to assess the quality of those questions and the test as a whole. An item analysis assists the instructor in determining the extent to which individual test items contribute to the overall reliability or internal consistency of the test, which means if you give this test multiple times to similar students, say for example, senior level students over a few semesters, that you will get similar responses, similar grades. An item analysis has in it some basic elements. They include measures of central tendency, correct group responses, response frequencies, non-distractors, and point-by serials, and a reliability coefficient. On the screen is a typical item analysis report. So across the top of this analysis report, we have the name of the exam, which is exam 3, and the version of the exam we're using, which is A. On the next line of a typical item analysis report, we see the course name, the course number, the instructor's name. Sometimes we'll have a description of the course, the day and time of the exam, and the term. In this case, it's fall 2008. On this line, we get some information about the actual exam. We know from looking at this analysis that there are 50 possible points, or in this case, 50 questions. We have measures of central tendency. For example, we have the median and the mean. A mean is simply the average of all individual student scores for this particular exam. In this case, it's a 39.92 out of 50. The median represents the middle point in this group of raw scores. So that's to say that it's the number at which 50% of all the scores on this test fall below the median score reported, which is 41.0, and 50% of the scores fall above the median score. Now, when you look to the right, you'll see the highest and lowest score on the exam. When you look at those numbers together, we get a range, or the measure of variability. And what we find is the range is just the difference between the highest and the lowest score. So a small range indicates a very concentrated distribution of scores, and a large range means that the scores are sort of spread out and that some students may not have done well on the exam. So in this example, the range is the highest score of 48.00 minus the lowest score, 26.00, which gives us an actual range of 22. Now, you see circled standard deviation, and we know that's another measurement of variability. It's the measure of dispersion of student scores, or how much on average the scores vary around the mean. It tells us the average distance of the scores from the mean, or how far away most scores are from the mean. Below the standard deviation is students in this group, and that is basically your N. That's how many students took this exam, and that is 36. finally, on this line, we have what's called a reliability coefficient. The reliability coefficient analysis is the overall reliability of the exam. We use two reported statistical analyses. One's called the Cronbach's alpha, and the other is the Kuder-Richardson Formula 20, or the KR20. And in this item analysis report, we use KR20. They both measure stability or consistency among test scores. So the higher the reliability coefficient, the more likely a test will produce consistent scores within similar groups. Like I said, senior level nursing students, all first semester FNP students, for example. You'll see the KR20 is indexed from 0 to 1. And basically it's a reflection of four things on a test: the total number of test questions, the proportion of the responses to an item that are correct, the proportion of responses to an item that are incorrect, and the variance for the test set of scores. So when you see a low reliability number, that could mean that the test questions are unrelated to each other in terms of who answered them correctly, and that the test scores reflect peculiarities of some sort, more so than they are an indicator of the student's knowledge on the subject. But most often the cause of a low reliability on an exam is that it's too easy. The exam itself is too easy. Another reason why you might have a low reliability is that there's an excessive number of very difficult test items. Another reason for low reliability includes unclear or poorly written items that do not discriminate, or test items that do not test a unified body of content. A high reliability usually happens when the individual questions on a test tended to pull together to measure one topic, and the students who did well overall were likely to answer each question correctly. So when we think about the range of scores, remember it's from 0 to 1. In nursing, a reliability coefficient of 0.50 or greater can be considered a good coefficient for nursing exams, because most nursing exams, well, they cover multiple concepts and topics. Even with multiple topics on a test like respiratory and cardiac, you have to understand that the central construct is still nursing knowledge. So anything above 50 is really, really good. You might see really high reliability coefficient scores in standardized tests, such as the NCLEX or ATI exams, and you might see numbers approaching 1. Ways in which we can improve sort of the reliability coefficient is if we administered longer tests. Well, that might be difficult to do considering that we only have a finite amount of time to give an exam. We can also improve reliability by having a more heterogeneous group of students. Another way to improve reliability is to attempt to change the questions and thus the item difficulty to where 70 or 80% of the students answer the test item correctly. So now we're looking at the actual analysis, and you'll see the number 1 through 8 on this slide, and basically that is the number of the question. Then you see an area called correct group responses. That's what we're going to focus on right now. When we look at the total percent correct column, that's a reflection of total percentage of students who actually answered the test item correctly. It's an indicator of the item difficulty. That is to say that we call this the p-value, or the percent of correct responses to a particular item. So the higher the p-value, or percentage correct, the easier the question. Ideally, we would like to see a p-value of about 0.50, or 50% correct. The upper limit is close to 1.0, and if you do have a 1.0 in the total correct column, then what that means is that everyone got that question correct, and that might tell you that it was too easy, or it's a question that you've already determined that you want to make certain students know this knowledge and expect 100% correct total. And you might want to do that in areas where you're testing patient safety or medication contraindications, things like that. So, you always want the student body to get that question correct. The lower limit of total percent correct depends on the number of possible responses and the probability of guessing correctly. So if we had a response that had A, B, C, and D, 4 responses, we might think that a p-value of around 25 is considered, or less, is considered that the student is probably guessing. So the best range that we would like to see is anywhere between 0.30 and 0.90. We tend to consider that to be an okay total percent correct value. Under correct group responses, we see an upper 27% and a lower 27%. And these are based on raw scores. And what the computer will do is place students into these two categories. So the upper 27% includes those students who received a raw score in the top 27% of the class. The lower 27% represent those students who received a raw score in the bottom 27% of the class. So if we look at an example, we might look at question item number 5. We see that 66.67% got it correct. Our p-value is 6.6 or 6.7. We can see that 60% of the upper 27% of the class got it correct, and 80% of the lower 27% of the course got it correct. We're going to skip over point biserial for a minute and go to correct answer. This column simply states the correct answer based on the answer key that you keyed in. So you got to double check your exam key to make certain these letters are correct when you do your analysis. Response frequencies. So what the computer does is for each question item, it tells you how many students selected each response. So if you look at line number 1, you see that 1 student selected A, 35 students selected B, and no students selected C or D. You'll notice the asterisk beside the 35B. That's because that is the correct response. Next, we're going to look at non-distractors. A non-distractor is an indicator of the questions that were not selected by any of the students. The goal should always be that there are no non-distractors. Even if only 1 student selected that distractor, it did its job. So when you look at number 1, you'll see that under response frequencies, you saw that C and D both had 0 responses. Well, that means that they're non-distractors. So C and D are non-distractors. That means no students selected them because they were probably easy non-distractors. And it would be our job to change those into true distractors for students. So we would want to modify those 2 responses before we give this exam again. Now, let's talk about the point by serial. What this is a calculation of test item discrimination. It's used to judge the quality of the question. It tells us how much predictive power a test item has and whether students who would be expected to answer a question correctly, the upper 27%, are actually doing so. So your book says a point by serial is a correlational association between the item score and the total test score. It's a measure that can tell us how well an item separates or differentiates between those students who answer an item correctly or incorrectly and have a high or low test score respectively. So the range of a point by serial could be anywhere between -1 and +1. So questions that discriminate well will have a point by serial correlations that are highly positive for the correct answer and negative for the distractors. So the higher the point by serial here, the better the examination item is at discriminating among students on the basis of how well they really knew the material. In this case, a positive point by serial will indicate to you that those scoring higher on the test were more likely to answer the question correctly. If students, you got to think about this, if students in the lower third answer an item correctly, more frequently than the upper third of the students did, then the point by serial will have a negative value. So you look at question 4, and we have a positive 0.3. But number 5 is a negative 0.16. As a general rule, think about this. Anything below 0.2 is considered a relatively poor question, and there probably is going to need some type of revision. Items with a value of between 0.2 and 0.3 are really good, considered to be fair, and sometimes they can be improved upon. Any items with a positive 0.4 to 0.7 are considered very good item questions. So now, let's go through some examples on how we go about interpreting this item analysis. And based on the item analysis sheet that we're using, I'm going to focus in on questions number 1 and number 6. So let's look at number 1. Number 1 says that under correct group responses, 97.22% of the entire student group, which was 36 students, got this correct. Remember, anything between 30% and 90% or between 0.3 and 0.9 is considered okay. Anything above 90, we've got to start thinking, whoa, is this test question really too easy? Well, let's look at how our students did. Those who scored in the upper 27% on the overall exam, 100% of them got this question correct. Then when you look at the lower 27% of the students who performed overall on this test, 90% of those got this correct. So to recap, our p-value is 9.7, high. The top students on this exam got this question correct, and even the lowest students on this exam mostly got this question correct. We have a point by serial of 0.42. We have a correct answer is B, and this is our response frequency distribution. One person scored A, 35 scored B, which is the correct answer. No one selected C or D. Well, those are our non-distractors. So we can see that the majority of those people we expected to do well on this exam did well, because 35 out of 36 picked B, the correct answer. That's why our point by serial is relatively high at 0.42. So How would we interpret this information? So let's go ahead and use what to do with test questions from our McCahey and Ball article that we had to read. Well, if we look at this, we see that if the upper third got it mostly correct, we're good to go. We have a positive point by serial. We have non-distractors. And then when you look at the second column, lower third got it incorrect. Well, it actually isn't that way. The lower third actually got it correct. So we can say two things about this question. One is that we definitely need to revise those non-distractors, which in turn will make this a harder question, because the second thing that we can interpret from this analysis is that this question is too easy. Okay, let's do another example. So this is from number 6. In this case, our total percent correct is 52.78. Our p-value is 0.53. That's sort of our ideal number. 80% of the upper 27% of those who scored on this exam got it correctly. 50% of the lower 27% of students got this question correct. That's a much better number. Our point by serial is positive at 0.17. Our correct answer is D. And that happens to be the most students selected D. And let's go ahead. And so every student selected at least one of the responses. So there are no distractors. So how would we interpret this? Well, we can look and say, okay, the upper third got it correct. A good portion of the lower third got it incorrect, 50%. We have a positive point by serial, and we have no non-distractors present. And what does that tell us? We could probably keep this question. It was a good discriminating question. We don't need to change anything. Let's look at example 3. We use a different analysis report, and we're going to look at question number 6. I just wanted to say at this time, if you want to practice, well, then you can go back to these slides and you can select another number and do the analysis yourself. So looking at number 6, in this case, we have a p-value of 0.40, which is good. It's between 0.3 and 0.9. The upper 20% of the class got an 87.5 correct. The lower 27%, 12.50% got this correct. The point by serial is 0.55, very good, very high number. Correct answer in this case was B, and you see it selected, but no one selected D. So our non-distractor in this question and responses is D. So how do we interpret this? Well, a majority of the upper third got this question correct. Majority of the lower 27 got it incorrect. Point by serial was positive. We had a positive non-distractor. Well, then in this case, all we need to do is revise that non-distractor, and we can continue using this question. Let's do example 4. And this is just made up. It doesn't come from any of the other item reports. So in this case, 47.37% got this question correct of all the students who took the exam. Of the upper 27%, 46.67% got it correct. Of the lower 27%, 40% got it correct. The point by serial is 0.06, pretty low number. There's going to be some issues here. We need to decide what we're going to do. A, no one selected A, so it's a non-distractor. 27 selected B, 17 selected C, 13 selected D. So let's look at these numbers. So if we have the upper third, a majority of the upper third got this incorrect because only 46% got it correct. A majority of the lower 27% got this incorrect. We have a positive or negative point by zero. In this case, we have a positive. We have one non-distractor present, which is A. And now we have to think about, wow, no one did really well on this question. We need to figure out why. Was this a problem in how we taught the content? Did we actually teach the content? Where is the problem with this? So in this example, I would agree that what we need to do is reteach this content because people clearly did not understand it. Now, before we end, I just wanted to remind you that an important thing here is to realize is that item analyses do not happen in a vacuum. You need to have with you the actual test and the answer key. And as you go through and select items that you need to analyze a little bit further, you need to be looking at the exam. I also take an opportunity to look at the content that was taught, how it was taught. If it was used on PowerPoint, I might review the PowerPoints. Then I'll determine if I want to keep this question or not. Okay? Thank you all so much. If you have any questions, just let me know.